continue discussing the remainder part in universal motor, and we will start inshallah in the single phase induction motor. So just to remind you by the previous class, I will start from the beginning. We saw that universal is one of the special motors. Then we understood the construction of universal motor. Universal motor can be supplied by DC and AC excitation. So we discussed the performance or curve and relations for DC, and also we derive the relations for AC excitation, okay, and the phasor diagram in AC excitation. طبعا in DC يا شباب there is no phasor diagram because DC is DC, it's not vectors, okay, which means everything are in phase. However, in AC there is a phase shift due to the power factor of the of the current and voltage phase shift, okay, because of the inductance effect of the motor. So this is the phasor diagram of the single phase or universal motor in AC excitation. For now, شباب, if we need to compare between the two effects by exciting the machine using DC and AC, what will be the response? And actually, we discussed this yesterday in one of the lab sessions. Today, inshallah, the other lab session will be inshallah conducted, and we will discuss details, experimental work, and the effect. But now let's discuss together the theoretical comparison between the DC and the AC excitation. One of the important parts that can be used in order to compare the evaluation is the internal EMF. So let's compare together the internal EMF. Why EMF is important? Because it will be a source for power يا شباب. Power, the developed power of the machine will be E multiplied by I. So it's effective part in terms of power and the machine efficiency. So let's compare the EMF in case of AC excitation and DC excitation to see what is the difference between the two excitations in universal motor. So firstly, for EDC, we can say EDC equals K multiplied by phi multiplied by omega, as we discussed previously, which in AC it's K multiplied by phi D. This is RMS value by omega. So this is here for AC, and this is for DC. And we can say it's approximately equal to omega, M DC over AC. So this is now the relation. So what about the difference between these values? Are the flux in DC and the AC equal? Sure, it's not equal. Okay. For instance, if we assume we are going to close to saturation, شباب, you will find that phi D or direct flux in AC will be slightly less than phi D in DC, which means flux here is less than the flux of DC. This means that the speed of DC excitation will be higher than the speed in case of AC excitation. If we have the same current, assuming we have the same value of current, so in this case you will find that the value of EMF will be different, and also the speed here will be different. So in terms of the relation between EMF and the current, we can say EDC equals V minus summation of R. This is in DC. In AC, in order to get the relation, let's return back to the phasor diagram again. Here, we can say that E equals the vector from this point to that point, this length, which is V cosine theta, minus IARA. So the value of E in AC excitation equals V cosine theta minus IA multiplied by RF plus RA. Okay, شباب, is it clear? So this relation is derived from the phasor diagram. Now, in order to simplify the equation and show the difference between DC and the AC, let's divide the equations in numerator and denominator, divide the equation by V. Okay, so the relation will be 1 minus I over V multiplied by summation of resistances. Here it will be cosine theta minus I over V multiplied by summation of resistances. Now, شباب, if we would like to compare these values to unity, for instance, I multiplied by R, this is considered as the voltage drop on the resistance itself. Actually, it will be very small compared to the voltage value, the terminal voltage. This is for all of motors. So since the voltage drop is very small, we can consider now this term is very small or compared to unity. So it's less than unity by a huge amount. So we can say neglect this value compared to unity and here as well. So we can say finally EDC over AEC equals 1 over cosine theta. And you know cosine theta is a function of if the power factor of cosine theta is right. صح يا شباب? Cosine theta is the power factor of the universal motor. What do you expect? The power factor of universal motor is going to be very small or very high or what? Can it reach to unity يا شباب? Here, this power factor. Can this value reach to unity or not?
I think cannot.
Cannot, because here we have R and L. This is right. صح يا شباب? You have inductive load along with the EMF, so all of time the power factor will be lagging. This is just like induction motor, شباب. So the value here will be less than unity all of time. So we expect from that the value of EDC will be higher than the value of E at AC excitation. So this is now, شباب, a comparison between DC and AC excitation. This means if you supplied the universal motor by the same voltage value in DC and in AC, and applying a load for a certain armature current, this will give you speed in DC higher than in AC. If we draw the characteristics, we'll find that this is for relation between torque and speed at different loading. And here we change the torque and observe the value of torque with the speed. At the same load current, if we make the test at the same load current, as you can see, شباب, at the same value of speed, you have different torque. صح ولا غلط؟ يعني if you said this is omega, and now you would like to calculate power DC and power AC, I mean mechanical power. So we can say now, this is omega, assume for DC this is torque DC, and this is torque AC. So power DC will be omega multiplied by torque DC, and power AC will be omega multiplied by torque AC. Since يا شباب the value of DC torque here is higher than AC torque, طبعا يا شباب I mean DC torque يعني it's torque equivalent to supplying the motor by DC supply, and I mean torque AC as the equivalent torque when you supply the machine by AC supply, because there is nothing called AC and DC torque, صح? And this is just a subscription for the used supply. And here يا شباب, since the value of T DC is greater than T AC, so for sure power in case of DC will be higher than power in case of AC. So this means if you supply the motor by the same voltage and current, so you will pay the same electrical power almost. In this case, you will have higher output power. Okay, شباب, in case of DC supply. So we can conclude finally that the efficiency in DC should be higher than the efficiency in case of AC supply. To be honest with you, we discussed previously, شباب, that universal motor exists a lot in our home appliances. However, in most of home appliances, there is no internal AC to DC converter in order to convert the AC supply to DC. This is in most of home appliances, because all of companies try to produce home appliances in a competitive price, okay? And if you include the power electronic converter, so it will need some digital controllers and the programs and like that, and it will increase the cost. And this is not suitable for home appliances applications. However, for industrial applications, for sure, we have to look for the high efficiency and the performance of our load, because in industrial شباب the power rating is high, okay, and the electricity bill, by the way, will be very high for industrial شباب. So we take care about supplying universal motors by DC, not AC, in industry applications, not in domestic loads. Now let's solve an example regarding universal motor. Here we have 120 volt, 60 hertz, 14 horsepower universal motor, runs at 2000 RPM and takes 0.6 ampere when connected to 120 DC source. So this is now the current at DC supply. Determine the speed, torque, and power factor of the motor when it's connected to 120 volt 60 hertz supply and is loaded to take 0.6 ampere. So it's the same condition as we said yesterday. We will apply the same current, not the same load. So the torque will be different now. Okay, but we will load the motor up till reaching to 0.6 ampere RMS value, similar to what we have loaded for DC. The resistance and inductance measured at the terminal of the machine are 20 ohms and 0.25 Henry respectively. So this is the value of inductance and this is the armature resistance. Now we need to obtain the speed, torque, and power factor. And we have the condition that you supply the motor by DC and AC and the current is equal. In order to proceed شباب and start calculating speed, torque, and all of this, we need first to obtain the impedance of the machine in terms of AC supply. So you have the value of resistance, but you don't have the reactance value. It's stated here the frequency is 60 Hz. So in order to get the value of XL, you can say 2 by F multiplied by inductance. So simply substitute in the reactance relation to get the value of XL. If you do that, you will find that XT equals 2 by FL, 2 by multiplied by 60 multiplied by 0.25 Henry. And this, by the way, it's a huge value. This inductance is huge value. So you can find here the reactance is 94 ohms. Can you see here also that the resistance is 20 ohm? Type. I don't know if you can memorize resistances in DC machines. Was it high like that, شباب, or it was a small value, lower than? Why, شباب? Why do you think the resistance here is high?
I don't know.
I think because field resistance.
We said, شباب, in case of universal motor, the resistance should be adapted, the brush resistance, so should be adapted in order to operate the machine with DC and AC. This is number one. Number two, the power here is not very high like the machines we compared in DC. Here the machine is not very low, it's not fractional horsepower, it's relatively high a bit, it's 14 horsepower, okay? But compared to DC motors, you will find the DC motors in high power application with very small resistance, maybe 0.1 like that, okay? So the reason why here the resistance is high because of the brushes of the universal motor, this is number one, and also because of the low rating compared to DC machines. Because, شباب, as you know, if you increase the power rating, this is needs coils with high cross-section area in order to carry the required current. And you know the relation between cross-section area and resistance are inverse relation. So, and you know resistance for any wire شباب equals rho L divided by A, which is the cross-section area of the wire. So if you have high rating machine, you expect to have small value of resistance. And for small rating machine, the resistance will be high. So as you can see here, it's high resistance and high reactance as well. So now we need to calculate the motor speed, torque, and power factor in AC. So firstly, let's start calculation from the phasor diagram here. We can get the value of EMF in order to use it and to compare it with DC to get the motor speed. And you know, in case of DC, the motor speed was given 2000 RPM. So we can now compare between the EMF in AC and DC, and you have the speed in DC, so you can get the speed in AC. So simply, we can say from phasor diagram here, E equals VT minus, VT cosine theta minus IARA. This is the relation of VA. Or we can get this length in terms of V square minus IAX square in order to get that length using Pythagoras. So VT square minus IAX square. This is now representing the vector here. Then minus IARA in order to get the value of EA. Substitute in the equation, simply you can get the value of EMF now. In case of DC excitation, شباب, we have the same value of current and you have the value of resistance. So simply we can say EA in case of DC equals VT minus IARA. So the DC voltage is 120, current is 0.6, so the EMF will be 108 volt. Now we can compare between the values of E in DC case and in AC case and compare it to the speed. So we can say finally N, or speed in AC excitation, will be 2000 RPM multiplied by E AC over E DC. So as you can see here, this is now the speed in case of AC excitation. طبعا it has to be lower than N in case of DC excitation. We need then to calculate the power factor. طبعا simply you have now all of values in the phasor diagram. طبعا you can, from phasor diagram here, you can say cosine theta equals E over V. Is it right? صح يا شباب? So we can say, sorry, not E plus IARA. صح? E plus IARA. This length. So E plus IARA over V will give you the amount of cosine theta, which is the power factor now. طبعا شباب, you have to take care all of time power factor has to be less than unity, because sometimes I don't remember at which exam or quiz many of you obtain the power factor greater than unity. طبعا this is شباب not acceptable at all. All of time power factor is less than unity, or maximum can be unity if the load is resistive load. Because there is no cosine theta greater than 1. In math, in terms of mathematical equations, the cosine function has a maximum value of unity. So it's not possible to have a power factor greater than unity. Fine. Because sometimes you are going to get the value of cosine theta here by adding and dividing some things. It may be you have any error in the or numerical error in the relations here, and you got value greater than 1. In this case, شباب, if you don't have time in the exam to review your answer, you just have to add comment. Just add comment. This value is not logical because it's greater than unity. This is the way, شباب, to write the answer if you don't have time to check your numerical solution, and it's acceptable for me. Now we got the motor power factor, we got the motor speed. We need also to calculate the motor torque. طبعا in order to calculate torque we don't have equation here for torque. يعني actually you know torque for universal motor, we write the equation torque average equals K series multiplied by I ARMS multiplied by omega. صح يا شباب؟ which is the motor speed in radian per second. Sorry, K series multiplied by I square. K series I omega, this is EMF. Now torque equals K series IA square. طبعا you can obtain the value of K series, okay, if you have if you compare, sorry, the value from the other equation, which is EMF equals K series IA multiplied by omega. صح يا شباب? So you can obtain K series from this relation. You have E, you have omega and IA. Then you can just multiply with IA squared to get the value of torque. This is one solution. Another solution you can do is to obtain the value of EMF multiplied by IA, which is the mechanical power. Then divide the mechanical power over the value of speed in order to get the amount of torque. As you can see, شباب, here the torque is very small, 0.3 Newton meter, because this machine power is not that high. By the way, شباب, we discussed universal motors are used for domestic applications which need high starting torque. Kitchen machines يا شباب, all of time you load the kitchen machine firstly, then you apply your supply to the motor, so you have a high torque, so it needs high starting torque. For that we prefer the use of the universal motor for high starting torque application, like in drilling, for instance, also. Okay. Now we understood the universal motor, how we can supply the universal motor. Here we have some circuits, however, it's not all of the circuits. We have many circuits that can be used to drive the universal motor. For instance, in case of DC excitation, we can use controlled rectifiers. This is the controlled rectifiers using thyristors, by the way. Okay, we may have PWM rectifiers as well. So this is one solution, controlled rectifiers, like the one given here, which is SCR controlled rectifier or PWM rectifier. And as you know, and you made already the activity number 5, PWM rectifiers are preferred compared to any other controlled rectifiers because PWM will produce lower harmonics, which will not affect the grid, like in case of controlled rectifiers using thyristors. This is number 1. Number 2, also it will improve the power factor. So controlled PWM rectifiers improve the power factor to be unity. It's controlled the power factor to be unity, which is not the case in any other controlled rectifier based on thyristors. So we prefer in industry to use PWM rectifier. Okay, this is number 1 for DC. Another shape, if you have already a DC supply, available DC supply, you can use class A DC chopper. This is one of the simple solutions to obtain DC supply, class A. However, here you cannot make reverse motoring, because sometimes in drills, for instance, you may need to reverse the motion of the drill itself. So in this case, we can use class E DC chopper, which is already we discussed previously in DC motor, class E DC chopper, which is the 4-quadrant DC chopper. This is in order to make motor reversal for the universal motor. Okay, in order to reverse the direction of universal motor. But if you are going to supply the machine by AC supply, you can use it directly connected to supply. However, if you'd like to control the voltage value, you can use very simple triac. Triac is nothing but back-to-back thyristor. It's AC chopper, and it's very cheap. Okay, it's used in dimming lamps. and the price is very cheap. Okay, طبعا يا شباب, because the loads of home appliances are very small. However, if you have high power applications, you can use instead back-to-back converter to have very smooth and controllable AC voltage control by means of controlling volt and frequency. Okay, so since we are going to discuss all of time the universal motor for the home appliances and small ratings, so these circuits are cheap circuits and can be implemented very easy. Now this is the time for activity number 7 يا شباب. I need from all of you to prepare a Simulink model for a universal motor. So you know now the equivalent circuit of universal motor, and you made a simple one before for DC motor, so you can modify. So you know now the equivalent circuit. You know the mechanical torque equation, it's similar to DC motor, nothing is different. So you just need to implement a simple model to include the universal motor in a MATLAB Simulink file and supply this motor by DC and AC source. After that, we need to check the performance or evaluate the performance of the machines in terms of the motor speed, the motor torque, the torque speed curve, which is like that. We already discussed it recently, and either having omega or T here, we can have omega here and T here. So the relation should be like that curve يا شباب. It's similar to series DC motor. Okay, so simply you can do that in MATLAB by using XY graph. There is a block in MATLAB can plot two terminals on two axes like that. It's called XY graph. So you can use it in order to plot the torque speed curve. After that, we need a calculation for motor input and output power. And at certain case, operate the motor close to rated value, and also calculate the motor efficiency. You can use شباب any motor parameters you need. Okay, here you have an example. If you would like to use the values here in this example, it's up to you. If you have or would you like to search for another motor parameters on internet or any book, and you can Google it and find any universal motor parameters, you can use it and make such simulation. This is just for motor يا شباب. I don't need to operate it from drive system or power electronic circuit, just the motor operation. Okay, so you will calculate the input and the output power for certain loading, and after that the motor efficiency. This inshallah should be submitted next week at Tuesday by the end of the day inshallah. Any questions شباب regarding the universal motor? Everything is clear up till now?
Yes, sir.
Okay, I will stop recording at this. تفضل.
Yes, regarding the activity.
Yes, تفضل.
Can you hear me?
I can hear you. تفضل.
Yes, yes. The model, you mean like what we did in the previous labs, and like we get the transfer function and we implement it.
Yes, but no need for transfer function. Transfer function is to see the response. If you would like to make it like that, you are welcome. No problem. But you can just implement. You can just implement the motor parameters, okay, and make the equations of the circuit in order to supply the motor and see the speed. This is all. Just you need to supply a motor and apply a certain load torque to see the motor speed. If you'd like to make it as a transfer function, and you can apply torque and supply, no problem. Okay. You can also use the MATLAB help, okay, or demo versions in motors in MATLAB to help you if you would like. No problem for that. The activity just aims to understand how you can model such type of motors and to exclude the motor performance in case of DC and AC excitation. Okay. For now, Shabab, I will stop recording this part to be included in the universal motor, and we will start a new recorder for single phase induction motor. So, let me stay with me.